number of cylinders based on position of cylinder according to method of cooling. Then we have discussed about different parts of an IC engine in the previous class. Okay. Then we were here, that is 4-stroke petrol engine, how the engine works, what are the different cycles, that is 4 different cycles. You can see this is called as the crankshaft. Okay. Yesterday in the rough sketch we had seen, if this is the piston rings. Okay. So whatever this region is there, it is called as the crankshaft. Okay, which is helpful in converting reciprocatory to rotary motion. You can see in the petrol engine, whatever we discussed yesterday, okay, in 2 complete revolutions of the crankshaft. 1 revolution means it will be 2 revolutions means 720 degrees of rotation of the crankshaft. 1 cycle will be completed. 1 cycle means once power will be developed. Okay, so why it is called as 4-stroke engine? 4-stroke. Yesterday we discussed this is torque that center, this is water center. Piston moves from one end to other end. One, this is called as 1 stroke. 1 stroke. Since the cycle, whatever the 720 degrees is there, this gets completed in 4 movements of the piston. It is called as 4-stroke. Right? See. Once again, we will discuss about the same petrol engine 4-stroke work. So this sketch will be very easy for you to draw in the exam, right? Yes or no? Okay. So what is the first stroke? Piston will be at the top dead center. Correct? It will move towards the bottom dead center. So as we discussed, what happens inside the cylinder? When it moves towards the bottom dead center, the vacuum will be created. Obviously, anything tries to move from higher pressure to lower pressure. Correct? You draw a balloon, put the cylinder in there, rushes of the air, correct? So that the balloon moves up. Similarly, wherever lower pressure is there, okay, anything it might be air, water, etc., it tries to move towards the lower pressure. Vacuum is obviously lesser than the atmospheric pressure. Am I right? Okay. So in the atmospheric pressure, whenever the piston moves down, the pressure gets reduced. So that this is the intake one, it gets opened in this circle, so that air enters into the cylinder. Okay, this is the first stroke. And the piston moves from TDC to BDC. So this will be the first stroke. You can see here, if I draw a graph of pressure versus volume. Okay. So those are the 2 important components in the cylinder, correct? One, volume will be varying, the second is pressure will be varying. Okay. So if I draw a pressure versus volume chart, you can see there, okay. Okay. A to B. What is happening from A to B? Volume is increasing. Correct? We are moving towards the right. So volume is increasing at a constant pressure. Correct? Next, what happens in the second cycle? You can see here. So the piston tries to move out in the second cycle, so that whatever the mixture, that is air and fuel, is present inside the cylinder, it will be compressed. Okay. So it will be compressed. You can see B to C. B to C. Volume decreases. Am I right? When the piston moves on, the volume is smaller. Volume decreases. Meanwhile, pressure. What happens to the pressure? This is P1. This is P2. Pressure increases. Right? So this is B to C, second stroke. Okay. Next. Similarly, when you come to the third stroke, what happens? At the end of second stroke, there will be a spark plug. What is its function? It will be timed such that every time the third stroke starts, it will give a spark. Okay, so that the high pressure mixture, whenever there is a spark, it catches fire and it starts burning. Okay, so it burns and releases energy. You can see C to D. Okay, C to D. The volume will be fixed here. Here starts burning. Once the burning is getting completed, okay, the pressure it will be such that so it will move the piston downwards. Pressure will be exerted on the piston. Right. You can see C to D is the third process. Okay. And what happens in the last cycle? Once the combustion is complete, the piston will be pushed down. So at the end of this, whenever it reaches BDC, an exhaust valve, outlet tap will get opened. so that the exhaust gases will start moving out. Why it moves out? Again, same pressure theory. Correct. Outside atmospheric pressure will be there. Obviously, because of fuel consumption inside the cylinder, pressure will be higher. So obviously, it tries to get out. Right. So this will be the next process. D3, and finally, when the piston reaches the TDC, this loop will be closed. This is called as the PV diagram of PV work. So what is the use of this? In any process, you can study what is happening to volume, what is happening to pressure. This is the suction stroke, this is the compression like that. In suction stroke, volume increases, pressure remains constant. Compression stroke, pressure increases, volume remains constant. So that you can study from this graph. Okay. So this is about the working. You can study this chart. Suction stroke, what happens? The piston moves from TDC to BDC. Correct. Inlet valve will be kept open. Outlet valve will be completely closed. Okay, there will be a timing mechanism. We are not going into deep. How that valve gets opened, there will be a separate timing belt. Okay. Next, crank will move from 0 to 180 degrees. So in this sketch, you have seen the crankshaft. In the first stroke, you can see number 1, blue color line, 180 degrees, it will move. Right. In the second cycle, compression, piston moves from bottom to top. Correct. So inlet valve, outlet valve, both will be closed. If they are open, what happens? If any one of them is open, what happens? Of course, correct. Outside atmospheric pressure is there. When you start compressing, pressure increases, it will try to move. So both the valves will be closed. Again, this crankshaft moves from 180 to 360. It completes one revolution. 2 strokes are complete. Correct. Coming to the third. In the third, what happens? Piston is moving from TDC to BDC again. Both the valves will be closed. 360 to 540. Another 180 degrees it will move. And finally, in the exhaust, BDC to TDC, the piston will move. So once these 4 processes are completed, okay, one cycle will be completed, and once you will get the required energy. This is about 4-stroke petrol engine working. See, any doubts you can ask me. So just for your understanding, I have downloaded one animation. See, the topmost portion, something is involving there. Can you see? It is somewhat like this. Okay, that is called as a cam. It will be connected to the crankshaft to the rod. Okay, so that whenever this part is moving, proportionately the cam will move. You can see during the first stroke, the tip of the cam, whatever is there, it will push the inlet one automatically. Right? During the second, third, fourth stroke, this portion of the cam will be in contact with the inlet one so that it will be closed. Okay, so it will be timed such that during the fourth stroke, outlet valve will be open. During the first stroke, inlet valve will be open. Clear? This is the working of the petrol engine. You can take down these 2 sketches, make it fast. 2 minutes. Next, we will go to 1 stroke.